This lesson we discuss construction safety and health, and we have two learning objectives: explain the importance of construction safety, safety programs, safety risks, and environmental health in construction. And the second objective, we explain and give example of design for safety. And many of you will become engineers. Believe it or not, whatever you design may play a key role in the safety of the workers when they execute and perform the work to make sure that your design uh, become a reality. So let's talk about the some concept of the construction safety and health and uh, equipment maintenance in these lessons. So before we get into the design for safety, we want to go some statistic about the construction safety and to see how important of construction safety that you can see here. Do you know what are the percentage of the U.S. workforce working in construction? Can you guess what is percentage of that? Or with that, what is the percentage if the work fatalities that construction account for? Whether construction is safer than other type of industry, just like manufacturing, mining, etc. And then, if you can answer that questions, otherwise you can Google to see that happen. What are the percent of this enabling injuries in the construction account for? What are percent? What are the annual costs of construction accidents? So with that one, I want to show you all of that information in the report here. So we have first to answer of those questions. You have construction occupational safety in construction in United States. So to answer the question is percent of workforce working in construction, percent of worker fatality that construction account for. Let's go back to there. And you can see here in the introduction, it available the link in the your slide. Workforce, only 7.7% of US workforce works in construction. But the suffer is disproportional, and you can see that 22.2% of the accidents happen or the death fatality in construction. So workforce plays 7.7%, but the fatality account for 3 times of that for the overall construction workforce. And the rate was that 71% higher than the all industry as a whole in terms of the injuries. So that answered your question there. And it also happened in construction costs. If you want to read further in the link that you have here, you can be able to determine it's very expensive when the including direct costs and indirect costs involved when the accident happened. So go ahead to see the link that I have it in here so that you can know more about the statistic of the safety and that importance. We have to emphasize always safety first in any workplace. And now today I give you some scenario, some example that you can be able to see your design. Your design may play a role, a good role, positive role in the construction safety. So before we get into the design for safety, we want to see what are the safety risks in construction. So when you know that, you can, when you design, you should be able to look at all of this. The typical risks in construction, including the struck by the equipment, between the two objects, things like that. Struck against the objects, caught in or compressed, fall to a lower level, just like the roofing worker fall out, or the trench, the excavation, fall to the excavation pit, that is fall to the lower level. For on the same level, if you got stuck, fall out, things like that, over exertion, repetition motion that may make fatigue, and it have a safety risk. Exposure to the harmful substances, chemicals, things like that. Transportation accidents and other. So those are the risks involved. Electricity cut, shocks, all of that. So with that, we recognize the safety. So we have the OSHA legislation involved, and that we call it OSHA, it means Occupational Safety and Health. You have a chance to learn about that when we do the excavation for foundations. Where it start a contract work hours standard act, and then it amended, it become a Construction Safety Act in 1969, and then included by the reference with the OSHA, Occupational Safety and Health, which was passed in 1970, Part 4, included by reference, and it also published by Secretary of Labor and published in the Federal Register 1971. We have a Part 1926 construction standards. We have a chance to introduce that in the previous lesson. And then Part 1910 is general standard. So that most of the construction safety it have in the Federal Register Part 1926 construction standard for the safety, including the one that we learned in the foundation construction, that is the sloping, benching when you do the excavation, shoring, etc. So what happens if a company gets some violation of the OSHA regulation? And you can see violation, it depends on what type of violations. And then administrative proceeding or criminal, if like willful or repeated, the same violation, 70,000 per violation. Routine or serious, $7,000 per violation. Failing to correct cited violation, it already violated but failed to correct, $7,000. Failing to post cessation near the place where the violation exists, so that we caught and know to try to avoid, also $7,000 per violation. For criminal, you also see that in here, if it's killing, maximum can be imprisonment, can be life sentence, maximum fine. So you see that serious when there is the violation or accident happen on construction site. With that, multiple safety program implemented at the constructor organization, formal safety program for all new employees, orientation at the safety, periodic refresher training for each worker. Even in FGCU, every year faculty and staff have a safety refresher at the beginning of the academic years to review what are the safety protocol, things like that. In the workplace, in the laboratory, if you work for the laboratory, you have that as well. Program that have the regular size visit by safety personnel to review and control the job hazards. Formal supervisory safety training program for all supervisors. So all of these are the safety program available that you can go ahead to explore. And then we have a safety procedure for the program, general, what are the equipment operation, who can operate, in what time, in what conditions. So construction plant, excavation, something we already talked about in the very first lesson of the second part of our class. Construction of structure, marine, and overwater construction. So all of that we need to have specific procedure for your time of work. Give you one actual from the progress report of the project in terms of the safety update. It's for you see this month they had 3 OSHA recordable incurred during this period, and you can see a different company, different subcontractor in this company have employee have some kind of incident involved, like a Titan employee fractured his left tooth when his co-worker lost grip on the rebar they were moving, and it stuck the worker on the left too. So you see that it happened to anyone, and even one for this power plant, 1 month they have three OSHA recordable incidents. And you also have the safety update in the progress report to see what is the lost time injuries, things like that in here. Also recordable injuries, year to date for rate, inception today from the beginning 11, inception today it means from the start of project, because the project can start can take more than a year, so that you have 2 times year to date, so calendar days. And then you have inception, it means from the project beginning, which may be last year. Lost time accident, they last seen last lost time accident. So if you have increases, it's good, it means no lost time for that one. And the second point, not also construction safety, the environmental health in construction also important. As you can see, the noise, the dust, radiation, it may not happen and cause the damage immediately, but it may affect the worker health over time. Radiation, toxic materials, heat, cold, and in this case you show you one example in noise, the noise level, if the in terms of decibel of the noise, and how far from the worker from the origin of the source of the noise. And you see where the zone communication easy, communication possible, it difficult, and some point like that it close to the noise, or the noise too lousy, then it too loud, then it communication impossible, and over time it affect the worker brain, things like that. Same for the dust, affect the lung, radiation, toxic material, heat and cold. So, and you can see by now, you see the importance of the construction safety. What are you as the engineer when you design the work? Play a role in ensure the safety, so that the concept of design for safety involved in here. So let's put the site right here, so that it, after the fact, the danger, someone fall down, get the accident, and that is too late. That reactive. You need to be proactive. And designer is play a key role in make sure that he is proactive, involved for the safety at the construction site. So example number one, and that you can relate that in many items, so that when you design in the future, you can be able to improve the safety for construction worker. Design components to facilitate fabrication in stock or at the grade, so that they may be erected in place at complete assemblies. Because the more the work in the indoor areas, just like at the fabrication shop, it's safer than you work on site with too many uncontrolled variables. So that was the suggestion. So if possible, when you design something, it try to be prefabricated rather than everything is on site, so that reduce the worker exposed to the force or to struck by falling object on construction site. The second example that you may consider is the design steel aluminum that you, I'm sure you will evolve at some point in your engineering career, with holes in the web at 1.53 and 1.07 meter. So it's about about 5.5, so it means 1.5 foot, and then 3 feet above the floor level to provide support location for guardrail and lifeline, because you see you need to have a guardrail, safety net, etc., so that when you put that the hole in advance when you do design, so that you can people later on can put the guardrail easily to protect the worker. So by eliminating the need to connect the special guardrail or lifeline connection, such as prefabrication detail, with facilitate worker safety immediately upon erection of the columns. Upon erection, they can put the gallery with the hole that you already provided and specified in the drawings and in specification. Example number 3 that you may consider: design underground utilities, just like you draw the design the water supplies, plumbing, foundation, etc., to be placed using trenchless technologies. So instead of open cut that have exposure, the excavation may collapse. Use trenchless technology that we talking about that in the few lessons before. So with that, you eliminate the safety hazards associated with the trenching, especially around the road or pedestrian traffic surfaces that you know in there. So now, even in our areas, many utility are placed with the trenchless technology. We don't need open cut excavation to install the pipe, water pipe, etc. Go through the road, river. Example number 4: design roadway edges with social to support the weight of the construction equipment. Otherwise, equipment might fall out, in that to prevent heavy equipment from crossing the edge of the roadway and overturning. Number 5, when you design, allow adequate clearance between the structure and overhead power lines. So it's very dangerous because the structure, we need the construction equipment like crane, mobile crane to erect. And when that mobile crane hit the power plant, it may get injury to the worker, fire, etc. So keep that in mind. So you can bury, disconnect, or reroute existing power lines around the project before construction begins, so that you can avoid that accidents involved with the electricity. Overhead power lines that are in service during construction are very hazardous when the operating cranes I just mentioned or other tow equipment involved. It may touch that power line and that accident will happen. So with that are the design for safety consideration. So when you design, you need to keep that in mind. And in the book for today, they also talk about equipment maintenance. So I don't go to detail, but equipment maintenance, either servicing, adjusting, and repairing of the equipment to make sure the good performance for equipment, the maintenance play a key role. And so that we have a preventive maintenance, don't need to be until the equipment break down, because that downtime, it costs a lot of money. Preventive routine maintenance before anything happen. And in the book, they also give you the preventive maintenance indicators, so that you see whether good preventive maintenance should take place. And equipment maintenance and repair and maintenance organization, all of that have detail in the book, but I don't want to get into detail in these slides, so that you can, if you interested in the equipment maintenance, you can go further in the book to read equipment maintenance.